Hi, my name is Noah Arnold, and this is my first physics lab for Physics 2212, and it is based on the charge tape experiment. Some key ideas for this lab will be Coulomb's law, which is basically a law of physics that describes the interaction between two charged particles a certain distance apart. We also will need to understand vectors and electric fields. Electric fields can basically be thought of as a charged particle has a field that affects everything around it. If it's a positive, the vector will point outwards. If it's negative, the vector will point inwards. And we also need to understand gravitational force. The purpose of this lab is to help us better understand the electric fields and the forces that they can enact on other charged objects around them. We also want to see the difference between the computational and the theoretical model. Some relevant models and physical principles that we need to understand is Coulomb's law, electrical field on the object formula. We need to understand the formula for force from an electric field and also the gravitational force formula. As you can see here in this figure, you can see the setup for this lab. Some basic measurements and calculations I have right here, and as you can see the preview for the lab, the charge of the tape ends up being negatively charged, and the system includes tape B with the surroundings being tape A along with everything else. Here's my code for the computational model. As you can see here, I wrote code to calculate for Q, Q1, R, and R hat, and I also set the electrical field force equal to the gravitational force for this lab. Here you can see the output from the code. As you can see, the orange arrows are the electrical force on each of the tapes, whereas the green arrow on tape B, the one that we are interested in, is the gravitational force. To the left, you can see the numeric output from this code, and as you can see, the charge ended up being this, which we will compare to the mathematical output on the next few slides. Next up, we use the theoretical model. So first thing we need to understand is that the magnitude of the tape 1 and tape 2 is the same for charge. We also need to understand that the magnitude for the gravitational force on tape B is the same as the magnitude of the electrical force on tape B. As you can see, after solving these equations, I found that the magnitude of the charge on tape B to be 1.86 times 10 to the negative 9th. From there, I went on to find the area of the tape and found that there are 3.6 times 10 to the 17th atoms in the tape, which was using the assumption that there is only one atom in the thickness of the tape, which is not right. And then also using the charge of an average electron to the charge that we found on tape B, I found that there were 1.16 times 10 to the 10th excess electrons, which means that there would be this many excess electrons per atom. Before we get into the computational versus theoretical, I think it is important to note that I found my tape to be negatively charged. Figured this out by taking a negatively charged pen after rubbing it through my hair, and it repelled the negatively charged tape. Now, for the computational versus theoretical, I found the same charge from the tape B, so it looks like it's successful, but this actually is probably due to the many assumptions that we had to make about this lab that might not actually be true in the real world. One assumption we made is that the tape is a point charge, when in reality this is not the case. We also assumed that tape A and B have the same but opposite magnitude of charge, when this could be inaccurate. We also, in calculating the atoms of the sticky tape, we assumed that the tape was only one atom deep, which is not true. All these things could have led to an error in the calculation, and also human error could have come into play by touching the tape. This leads us into the why question, and touching the tape could lead to some loss of charge in the tape. And what if electrons and protons were changed charge? I'm not sure that anything would happen other than a change in convention, but if protons, which belong in the nucleus, became negative, it could lead to a breakdown of everything we know about physics.